All right, this is section 2-1, patterns and inductive reasoning. So this is really our start of this whole chapter is really our start of the foundation of proofs in geometry. So a very good fundamental chapter to just look at too. Let's start with some vocabulary. So tell whether the statement is a conjecture and explain your reasoning. All right, so all apples are sweet. Is this a conjecture or an opinion or an idea? Yes. Okay. And why? Because it is an opinion. Okay. The sun sets in the west. Is this a conjecture? Well, no. And why not? Because it is a fact. All right. So vocabulary here, reason. So some related words to reason are reasonable, which is an adjective, and reasonably, which is an adverb. The definition of reason is that it's an explanation. So a logical argument uses reasons to arrive at a conclusion. So I need to defend why I can make a conclusion about something. So let's complete each statement with the appropriate form of the word reason. All right, so for the noun, in a logical argument, we state each reason. The adjective, the student did a reasonable job on the last math test. The adverb, the workers cleaned up reasonably well after the party. And then the verb, to make a good decision, we reason together. All right. So let's write an R if the estimate is reasonable, or U if it is unreasonable. All right, so let's see, 30 plus 11, let's estimate. So that's 30 plus 10, that's 40, plus 6, that's about 40, not 60. I'm going to say that's an unreasonable estimate. A 15% tip on $36. All right, so let's say that was $30. 15% would be 10% of 30, which is 10, plus half of that, which is $4.50. So I'm going to say that's a reasonable estimate. Okay. All right. So let's find and use a pattern. What are the next two terms in the sequence? So here's 45, 40, 35, and 30. So what are the numbers doing? First thing we have to think about. Well, they're decreasing. Are they decreasing by different amounts or the same amount? So vary means to differ, and constant means to be the same. It looks like they're decreasing by the exact same amount, so it's a constant decrease. Which operation helps you find the next term? Well, subtraction. And by how much to get to the next term? 5. So then if I continue to subtract 5, my next number would be 25, and my next number after that would be 20. Okay, so let's use inductive reasoning. What conjecture can you make about the first 20 terms in this sequence? RWB, RWB. Let's complete the table. So the letter in the sequence, R is 1, W is 2. B is 3. R is 4. W is 5. B is 6. Okay. So there are 3 letters in the pattern before it starts repeating. RWB, RWB. R is the first term, 4th term, 7th term, etc. W is the 2nd term, 5th term, 8th term, etc. And B is the 3rd term, 6th term, 9th term. So underline the correct words to complete the sentence. Then the 21st term is one more than a multiple of 3, 2 more than a multiple of 3, or is it a multiple of 3? Well, it's a multiple of 3. So if it's a multiple of 3, which of these is a multiple of 3? R's, W's, or B's? I think it's going to be a B. And that's how we determine the next pattern. All right, let's collect information to make a conjecture. So what conjecture can you make about the sum of the first 30 odd numbers? Let's complete the table. So the first odd number is 1. The second odd number is 3. When I add 1 plus 3, I get 4, which is the same as saying 2 times 2. Well, now I have 1 plus 3 plus 5, which is 8, which is 9, which is the same as saying 3 times 3. The next set, I have 1 plus 3 plus 5 plus 7, which equals 16, which is the same as saying 4 times 4. The next one, I have 1 plus 3 plus 5 plus 7 plus 9, which is 25, which is the same as 5 times 5. Look at this. It looks like the sum of odd numbers are the multiplication of two of the same number. In particular, they're the square numbers. So let's see if I can make a conjecture about that. The sum of the first 30 odd numbers is 30 times 30, or 900. And how did I figure that out? Because look at this. The sum of the first odd number is 1 times 1. The first 2 odd numbers is 2 times 2. The first 3 odd numbers is 3 times 3. The first 4 odd numbers is 4 times 4, etc., etc. All right, so that is how we make a conjecture. We look for a pattern and we make a conjecture from it. All right, let's make a prediction. So what conjecture can we make about backpack sales in June? So here's the month. November, December, January, February, March, April, May. So it looks like they're decreasing, okay? So let's write true or false in these statements. The graph shows a pattern of points. Is that true? Yes. So each month, the number of backpacks sold increases. Is that true or false? I think that's false. I think it decreases. The change in sales varies from month to month, so you need to estimate this change. So it's a little bit different here and here. So that's true. It does vary. So we have to estimate. If sales change by about 500 each month, I could subtract 500 from April sales to determine May sales. That's true. If sales change about 500 each month, you can add 500 to May sales to estimate June sale. That's false. That's going in the wrong direction. So let's make a conjecture. So if April is around 8,500, and I subtract 500 to get around 8,000 for May, and I subtract another 500, I'm going to get approximately 7,500 backpacks sold in June. So I just made an educated guess to figure that out. All right, let's look at a counterexample. So a counterexample proves a conjecture is false, basically. So if a flower is red, then it's rose. Well, is that always true? Are all flowers that are red roses? So let's find something that makes that false. All right, circle the flowers below that can be red. Well, roses obviously are red. Are bluebells red? No, I don't think so. Carnations could be red. Geraniums can be red. And tulips can be red. So is every flower I named a rose? No. So write a word to complete the counterexample. A blank is a red flower, but is not a rose. So we can pick any of them we want. How about a carnation? So a carnation is a red flower, but it is not a rose. So we just found something that proved this conjecture false. Okay. So let's do this one. Clay thinks the next term in the sequence 2, 4 is 6. Given the same pattern, Ott thinks the next term should be 8. But Stacy thinks the next term is 7. What conjecture is each person making? And is there enough information to decide who is correct? All right. So choose the letter that describes each rule for the sequence. So 2, 4, 6, 8, what would I be doing? Well, I would be adding 2 to each. 2, 4, 8, 16, I would be multiplying by 2 in each. 2, 4, 7, it looks like I'm doing something here. I don't know. Add 2, add 3, add 4. I think this is supposed to be 11 in the notes. All right, so Clay's conjecture would then be C. Ott's conjecture would be A. And then Stacy's conjecture would be B. So are 2 numbers enough to show a pattern? No, we need more than 2 numbers. And that is the end of section 1.